These are the results from my very first lab tested of my home batch of Reuteri yogurt. Now, I know what some of you may be thinking when you look at these numbers, but I promise you, they're a lot more promising than at first glance. Now, before we jump to conclusions, I really want to dive into this with you and show you why I'm enthusiastic about these results and why I'm not, I'd like there to be a little bit more Reuteri, but the concern about the Enterobacter is really easily fixed, and I'm excited because we are a lot closer to an end result than I think that we thought we were at beforehand. So let's dive in. Now, what I've shown you actually first is a screenshot from my website. You can go to the website to check out what I've done, how I've presented it. And so what you'll see is that there is a home Reuteri page, brand new, made by yours truly. And then there is a subsection that goes over the results of this Reuteri project, lab fermentation, and the results that we got. Then, if you would like more information, or if you'd like to get a handle on what it is that we're really looking at and why, I created an Reuteri resource section for the methodology and what this actually means. What is it that we are really measuring and why are we measuring it? When we look at the NGS PCR test, we're going to get a whole global view of the microbes that were present. But the limitation is that we can't tell if these microbes are actively alive or if they were at one point alive and maybe we're measuring dead cells. And so that's the reason why we're not just doing one test. There's a whole bundle of tests that we're doing, which will come up, that will go over and tell us what, first of all, and this is the first test that we've done, what microbes are present, dead and alive. And then next, we're going to look at what are the total active CFU units of everything that's in there, and then how many CFU units of actual Reuteri are we going to be working with here. All right, so when we look at this, I am going to see that there is a presence of Streptococcus Thermophilus. This is a regular yogurt or even fermented dairy product microbe. If you've had any fermented dairy in your life, you have eaten this specific type of microbe. It's everywhere. And so this one we are not really worried about. Next, we have Enterobacter, and we'll talk about this one. And then we have Reuteri present. Now, when we talk about there being an NGS PCR test, we have to keep in mind, and I already mentioned this, that it measures the DNA of a microbe doesn't necessarily go away when it dies. It still is present within the medium, and that is what is being analyzed. Just the active DNA that was present at some point during this fermentation process. And it says it's going to spit out, it's this one, it's this one, and it's this one. And so these are the three main microbes. And honestly, it's really promising to have something that has a rather tight microbial balance as opposed to something that is, if we had 15 microbes in here, that would be a lot more difficult because it would mean that we'd have a big contamination somewhere. And our only real concern here is the Enterobacter, and there is a very easy solution to this specific, I'll call it a contaminant, but it's an opportunistic bacteria. So before we talk about the Enterobacter and that being our main concern, I do want to touch on the Streptococcus Thermophilus. Pay attention to the way that is pronounced. It is thermo, which is heat, philus, meaning it loves that. So it likes the warmth. It's a Streptococcus type of microbe that likes a warm environment. Streptococcus Thermophilus. This one is one of the two main microbes that you find in just casual, regular yogurt. You have the Streptococcus Thermophilus, and then you have Lactobacillus delbrueckii bulgaricus. These are the two main microbes that you find in yogurt. And then you can also find it in a bunch of other dairy ferments. If you were to do sour cream, if you were to do milk kefir, if you were to do cottage cheese, you would most likely have that specific microbe somewhere in the mix. And so what I'm getting at here is that the fact that this microbe was present is technically a good sign because it means the environment was conducive to this really regular dairy ferment microbe. It means that our space was conducive to good dairy fermentation, which is honestly a really nice check mark for us to have. And so we might be asking, where did this come from? So previously, I used a jar like this, and these are my little mini yogurt jars. And a certain overlook that I unfortunately did was I used these and I washed them with hot soapy water. I did not sterilize them. I did not sanitize them. And something that I forgot or I was more unaware of is that Streptococcus thermophilus makes biofilms. Biofilms are these microbial protective gels that are resistant to heat and water, and it just makes it so that these microbes can stay long term. I'm sure that if I took this clean, I've been touching it, but if I had just washed it with hot soapy water and I were to put milk in it, that I would get Streptococcus thermophilus in here because it is encrusted into the walls of this jar. And now I'm not saying that it's a mistake, but what I'm saying is that these biofilms exist, and this is the reason why some of these dairy ferments have lasted for generations, thousands of years. French yogurt or Bulgarian yogurt or Turkish or Russian, any kind of like dairy ferment has stood the test of time because of the resiliency of these microbes. And the fact that it's on my jar wall makes sense. And so what does this mean? It means that if you're going to use a specific type of jar, you probably should consider either completely sterilizing your jar. So yes, sterilization is completely necessary, and no, a 70% ethanol wash is not enough. It needs to be within boiling water or sterilized in the oven at a high enough temperature for these biofilms to be destroyed. Yeah, it can be a pain in the neck, but I want to say maybe the sterilization is not really that necessary because it's entirely possible that at the end of this, we find that doing something symbiotic would be more beneficial for the L. reuteri to survive long term. Maybe what happens is there's a Streptococcus thermophilus microbe plus L. reuteri, and they work in tandem with one another, just like how Lactobacillus delbrueckii bulgaricus, so French yogurt ones. My French yogurt jar has Streptococcus thermophilus and Lactobacillus delbrueckii bulgaricus in it. If we take that French yogurt microbe out and replace it with L. reuteri, possibly we could have a symbiotic relationship that is more sustainable long term and creates a easier to maintain dairy ferment. It's entirely possible that as we look at culturing L. reuteri, that a monoculture, one that only contains L. reuteri, would probably be really hard to do and make in a commercial kitchen. And so instead of trying to force something difficult to work, maybe the L. reuteri would have a higher success rate, less contamination as well, if it was paired with a microbe where they mutually benefit one another. So if you would like to learn more about this type of topic, I actually have already talked about this about 10 months ago in this video, where I talked about, maybe L. reuteri gets paired with, as a third microbe into French yogurt, or maybe it's the Streptococcus with the L. reuteri, or maybe it's L. reuteri all by itself. And so one thing to keep in mind is that monocultures in dairy products usually don't last very long and aren't really that popular. When we look at dairy products, there's usually a symbiotic relationship happening there, and I think it would be short-sighted of us and our project of what we are fundraising for to discount how dairy products like to be fermented. They like to have symbiotic relationships. And if we're wanting to be really diligent about having only L. reuteri, which is maybe short-sighted, it's entirely possible that as we do this, we find a way to incorporate this wonderful microbe that we like so much so that it gets invited to a microbial party that's in a regular fermentation medium. Having it all by itself, I don't know how sustainable long-term that would be or how good of a success rate that would have. What does that mean? It means that we should have L. reuteri as part of a grouping of microbes, maybe not all by itself. And if you're wanting it all by itself, then maybe what happens is you just end up taking only the probiotic capsule rather than trying to force it into a ferment that has a lower success rate. So that's one option. If we're going to do L. reuteri in dairy, we have to consider, is it going to work as a monoculture? Maybe. Is it going to work as a symbiotic culture? I think that's a little bit more likely. And how do we optimize the medium so that we keep L. reuteri as high as possible? Now, when we looked at the results earlier, there was only 2.7%. If we solve for the Enterobacter, which we'll get to, which has an easy solution, and the L. reuteri replaces the Enterobacter in percentage, we'll have an end product that genuinely works, and we will have already succeeded in this short amount of time. But I don't want to get ahead of myself. If, however, we want to consider doing L. reuteri in a non-dairy ferment, maybe we lean more towards doing it in a fruit carrot juice blend. Maybe it gets put into a different type of medium that is non-dairy based. But we'll go through that and we'll have group voting and we'll talk about where do we want to go next after this fundraiser. And so I guess, do stay tuned as we keep talking about this and we get more results. Now, one last thing before I move on about the Streptococcus Thermophilus and how it is in the presence of yogurt, traditional yogurt fermentation. When you look at this specific study that I found online, you can see that the percentages of Streptococcus thermophilus plus its partner, usually there's a lot more Streptococcus and then there's maybe it's either a 1-to-1 ratio or there is a 2 parts Streptococcus to 1 part of its partner, whether it be yogurt or whether it be L. reuteri. So if we solve for the Enterobacter, it's entirely possible that we get real close to that specific type of ratio. And even when we look at some of these formulations online, the Streptococcus thermophilus, it's in a correct amount. It's not a surprising quantity percentage that we got. And also, we have to keep in mind that right now what we're looking at, these are maybe a mix of dead and alive cells. There are more generations of Streptococcus thermophilus, and it is entirely possible that the percentage we're looking at is multiple generations. And so the live active cultures are probably going to be noticeably slightly less. We're looking at Streptococcus thermophilus, which has generations every 30 minutes, and L. reuteri, which has generations every 2 to 3 hours. So they're just slower to grow. And so when you compare the two, it's normal to have one that has this much more compared to this much more, just because it grows that much faster. All right, so now let's move on to the second organism, which is the Enterobacter Cloacae at 11.6%. This one is the real concern of this batch, and I made an unfortunate oversight here. I used UHT milk, and I had opened it for about 2 days. And this was for me to look at and use it. I poured it into a coffee one morning, the morning before, and I had overlooked the fact that as soon as you open up a UHT milk carton, it is no longer sterile. Now, and so you will have these vegetative or psychotroph bacteria that will proliferate even in refrigerator temperatures. This is how milk, even if you're very diligent about keeping it in the refrigerator, it will still go bad after a few days. Now, this Enterobacter Cloacae is an opportunistic microbe and it should not be there. But when I opened up the UHT milk, I unfortunately broke the sterilization chain. You can solve this though. It was an oversight on my part, but when I heated up my milk, because I did it to denature the proteins and to repasteurize, but what I did is I just heated it up to 90 degrees Celsius, about 190 degrees Fahrenheit, and once it hit that temperature, I killed the heat. What I should have done is done a 5-log reduction phase, which is holding the milk hot enough at this temperature so that it killed all of the Enterobacter Cloacae. So what that means is that if I had, let's say 10 to the 5 or 10 to the 3 or 4 of this Enterobacter Cloacae in my ferment, and it had 5 logs of growth in there. When you heat it for 2 minutes, it goes down 1 logarithmic section. And then you heat it for another 2 minutes, it goes down another logarithmic section. And then another 2 minutes, and then another 2 minutes, and then another 2 minutes. When you hit 10 minutes, you effectively kill, it's like 99.99999% of all vegetative microbes that can be existing in opened milk. Unfortunately, I did not hold it at that temperature for long enough to kill the Enterobacter. But the good news technically is it's an easy fix. That means that whenever you make this type of L. reuteri yogurt, you have to, and if you've opened up the milk, you have to heat it for at least, and you have to hold it hot for at least 10 minutes with a thermometer. And I know that some people are going to maybe not like me doubling down on heating the milk, but if you're gonna make yogurt, you have to heat the milk. And so this is just being a studious home scientist, and heat up the milk 10 to 20 minutes even, if you want to be extra careful, and then transfer it to a sterile jar and then inoculate. Easy. And so what this does is, because we can effectively identify where this infection, contamination came from, open milk, and we know it makes sense. When I went back and looked at my record videos, I saw that I had just heated it up and then I killed the heat, and that was all I did. And I saw that this was the concern. It really solidified the fact for me that when I make L. reuteri whatever, or when I ferment a dairy of any kind, and it needs to have this heating process, that I really make sure that I hold it for 10 minutes at this temperature, because that's how you ensure that your dairy product isn't getting contaminated by some opportunistic microbe, because this Enterobacter Cloacae has no business being in our ferment, and it's not necessarily bad for health. It is present in all of our microbiomes, but you don't want to be actively consuming it. It would be like you consuming almost bad spoiled milk on a continuous basis. You don't want that. You want to have fresh milk. So, quick recap. The Streptococcus Thermophilus was from a previously used yogurt jar, and it had a biofilm. What's the solution? Use a never before used jar, or sterilize your jars by using a boiling method. Next, the Enterobacter Cloacae. That contamination came from opened milk that wasn't heated for long enough. So use clean jars, cook the milk for long enough. Easy. Next, when we move on to the L. reuteri, this is what we see. We see that it was there, and in the presence of an opportunistic bacteria and of Streptococcus Thermophilus, it still grew. And these two microbes are creating intense competition for the L. reuteri, which is a noticeably weaker microbe. We know this. We know that it's slower. We know it's not as aggressive of a fermenter compared to these other ones. And so when we solve for the cooking and making sure the opportunistic microbe isn't there, it's entirely possible that we'll get a Streptococcus Thermophilus plus L. reuteri, or, and this will be our next trial run when I send off my next batch, is just plain Reuteri as a monoculture. And so what will happen is I will heat up my milk for about 10 minutes. I'll put in 1 probiotic tablet in here. I will, let it cool down to about 40 degrees Celsius. I'll put it in here. I'll shake it up with the probiotic tab. I'll let it dissolve and it will be shut, closed, and it will not be opened until the lab opens it. And so what this will do is it will solve for, there will be no Streptococcus Thermophilus influencing it, and there will be no opportunistic bacteria influencing it. And so what this will do is it will answer, does Reuteri work as a monoculture? So we'll see. Now, for those of you who are just now tuning in, I already sent in 2 of these jars to the lab, and unfortunately one of them broke while it was at French Customs going into the US for specific CFU measurements. And so the lab contacted me and they said, we need you to send another batch, please. And so what I've done is I've taken these results and I've said, well, I'm not going to send in the exact same recipe because it's obvious that I have this Enterobacter concern. And so I don't want to measure that. So I'm benefiting from this happy accident to really update my protocol, make sure that I'm extra clean, make sure that I'm using jars that don't have the Streptococcus Thermophilus on its walls, and we will see what live active microbes are in it. So yeah, it's unfortunate that the jar broke, but maybe at the end of the day, it's not such a bad thing after all, because it does give us more context on how we can be more successful. So as we wait for me to send in this next batch and for it to get shipped, let's have a conversation in the comment section below. What do you think about doing a monoculture or having it be more of a symbiotic culture? Maybe instead you want to do something more along the lines of a carrot juice and blueberry ferment, or maybe we want to branch out to others, L-gaceri. Maybe we want to look at other types of fermented products. Maybe this is fun, but maybe you just want a casual like kombucha tutorial. All types of ferment. I want to do all of it, and I'm really liking doing these types of experiments with you guys and showing how I work with fermentation as someone that's got about 10 years of experience in the field. In any case, I do think that the new hypothesis or thought project on is Reuteri something for a monoculture, or should it be worked with in more of a symbiotic relationship? We shall see. Also, if you are interested, you can watch this video that I've already mentioned if you want to hear more about the symbiotic versus monoculture relationship. So hopefully what happens is we get interesting results from this next batch, and from there we can make an even more refined recipe. And what this will do, this will open up another fundraiser that we do, if you guys are still interested in continuing. I am, obviously. If you've been sticking along with me during this entire process, I want to say thank you for joining me in this journey, and thank you for donating if you have. I've been having a lot of fun doing this and pulling it all together. I really hope that you guys like my new updated website with more information on Reuteri and how we approach this new scientific endeavor research project. I want to thank you so much for watching this video. My name is Matthew Kress of Kress Dietetics. You can find me at kressdietetics.com, and I will see you in the next video with hopefully some more results. Thanks for watching. Bye.